So here we have two different atoms of chlorine, and you can tell it's chlorine because they have the same chemical symbol Cl, and also they have the same protein number 17. So anything with the proton number 17 or the atomic number 17 is chlorine. But what you might notice is that they do both have different atomic masses. And what's going on here is the mass number is different. So these are what we call isotopes of chlorine. And this is interesting because actually if you want to write down the relative atomic mass for chlorine, what should we put? Should we put that it has a mass of 35 or 37? And this is where this concept of relative atomic mass actually comes in. And we can actually say that with chlorine particularly, it has naturally occurring isotopes. And so the relative atomic mass, it wouldn't be 35 or 37. What we want to do is produce an average value of the two. And the way we do that is we don't just add them up and divide by 2, because actually some of these might occur more than the other. What we notice is that in a sample of chlorine, we could have 75% of our chlorine is of this type with a mass of 35, and the remaining 25% is of this type with a mass of 37. So if we want to write down the relative atomic mass, then we want to calculate the average value. So the way we do that is we want to take the total mass, and so I'm going to write relative atomic mass like this, AR, this symbol, and basically we want to write the total mass divided by the total number of atoms. And so here we've got percentages, so I'm going to show you how to do it with percentages, and it works very similarly if you have actually numbers of atoms as well. So essentially with the percentage, we pretend that there's 100 atoms, and so to work out the total mass, then essentially we've got 75 atoms of mass 35. So we can write 75 times by 35, and then we need to add this to the number of atoms that we have over here. So we've got 25 multiplied by the mass of 37, and that will give us our total mass. Okay, so we need to account for the fact that we've got two different isotopes here, and then we want to work out the total number of atoms. So because this is a percentage, it's very easy. We can just say it's 100. And so if you put this into a calculator, what you should end up getting is an answer that rounds to 35.5, and actually that is what we'd put for the relative atomic mass for chlorine if we had these percentages. And actually this is similar to what you'd find is naturally occurring on Earth. And so if you look at chlorine in the periodic table, which you can do over here, you will notice that it has a relative atomic mass listed of 35.5, which is interesting because we said that this number is a combination of the protons and the neutrons. And actually, how can you have half a proton or half a neutron? Well, now we know where this comes from. It's the fact that you have naturally occurring isotopes of chlorine, and therefore when we work out the relative atomic mass, then we need to use an average like that. Okay, so let's do a few questions to see what you guys understand, and then we'll leave the video off there. Okay, and so we just want to work out the relative atomic mass of a couple of questions below, so feel free to pause the video and have a go. Okay, let's run through the answers now. So the first question, work out the relative atomic mass of a sample of magnesium below. And so we've got 26 magnesium and 23 magnesium in 80% and 20% proportions. So what we do is we do 26 multiplied by 80 and add that to 23 multiplied by 20, and this gives us the total mass, and we divide that by the number of atoms. So because it's a percentage, that adds up to 100, and you can put that into your calculator and you will get 25.4. In this case, our relative atomic mass for this sample of magnesium would be 25.4. And we can do the same thing with question 2 here. This time instead of percentages, we're giving atoms directly, but it's the same approach. So we do a sample of X 100 multiplied by 4 atoms plus 200 multiplied by 3 atoms, and you divide it through by the total number of atoms, and so that's 4 plus 3. And again, you can use your calculator for this, and you should get approximately 142.9. Okay, so hopefully everyone got this correct, and I'll see you in the next one.